Alright, so we had to find now Vthevenin. Now you can actually find Rthevenin and Vthevenin in any order. I just happen to do Rthevenin first. Okay, so let's look at Vthevenin for a second. Let's talk about Vthevenin. Okay, so Vthevenin, this one is kind of it's a point of confusion, and this is one of the reasons why I recommend doing this on a brand new clean sheet of paper for each redraw and each little piece of the circuit. So now Vthevenin, basically we want to find, if I've got my A and my B, let me get a different color here. If I've got my A and my B defined, right, where R3 was connected to the circuit or connects to the original circuit. Now Vthevenin, I want to know what is the most voltage that I could ever see between points A and B. So if I took R3 out of the circuit and had my original circuit with 25 volts applied and 1K here and 4.7K here, okay, so now I remove that load completely, and so basically if I removed R3 from the circuit, I opened it, so therefore its resistance is essentially infinite, or you could think of it as really big, as big as it could ever be. So now A and B, or the points A and B, would now have available the maximum voltage that this circuit could ever provide between points A and B. So if I had my voltmeter here and I measured with my black lead and my red lead just like that, so removing R3 from the load, what would I measure between points A and B? Now this circuit's it's actually really easy to see. Hopefully you can see that. If not, take a moment and look for it. So in this circuit, if I removed R3 and looked for the voltage at A and B, once I've done that, I can see that the voltage of R2 would increase to its maximum level, and that voltage of R2 is going to be Vthevenin. So Vthevenin is my A to B voltage. In this case, it's just the voltage of R2 with the load removed. Now that's all fine and dandy, but you can see now my pattern recognition part of my brain is, got to look at this circuit, and I've got to remove some things mentally and look for those relationships. I recommend going to a clean sheet of paper and then redraw the Vthevenin circuit with those steps applied. Now I didn't write them down, so can you remember what are the steps? Well, Vthevenin, most voltage, let's say maximum voltage, let's say max voltage that, let's say given circuit could ever provide between points A and B. Alright, so Vthevenin is the max voltage that the given circuit, or a given circuit, could ever provide between points A and B. So that's basically defined as where the load was, or that component you're analyzing was. So the steps: open / remove load, which is just your target component or network. In this case it's R3. Open and remove the load. solve circuit. Wow, I don't know what that is. Solve the circuit with all given values and load removed. Okay. Thevenin equals VAB. Okay. Just as if you were to put your voltmeter right on A and B with that load removed. So in fact, if you build this circuit and then remove R3 and then measure where R3 was, you will see on your meter Thevenin. Okay, so we can predict it, we can build it, we can see it. Okay, so I recommend that we do that. Okay, so I'm going to draw my Thevenin redraw, decluttered for my brain to help out the old brain. Okay, so there's my original given voltage. Okay, R1, R2, and where was A and B? Don't lose track of that. Okay, so R1, let me line that up. So R1, R2, and A and B, and I have not lost track of A and B. Okay, hopefully. Okay, so now I can see a little bit more clearly. Now this is what I recommend, you know, define your steps and know what you need to do. Start on a clean piece of paper without any other calculations or any other circuits drawn, and just you know, solve this little circuit by itself. This Thevenin redraw is its own little isolated circuit, and the values here, other than the VAB voltage, will not be, you shouldn't take those to another circuit and try to use them, because it won't make sense. Alright, so clean piece of paper. Now I can see I just need to solve this little circuit, 1k ohms, all the original values, 4.7k. So now I should see, with R3 removed, my Thevenin voltage is going to be bigger than it would with R3 present, and it's going to be the most this circuit could ever provide. Okay, so let's go ahead and solve this little circuit. Okay, so I know I have a RT for just for Thevenin. Okay, so whoa, our total for this little circuit is going to be R1 plus R2. Our total for this circuit is 1k plus 4.7k. That should be 5.7k ohms. Alright, well that's all good. Now I can find current. Let's just look at that current. So in this circuit I've got current, I'm in electron flow. I total for my Thevenin redraw, only my Thevenin redraw, is just, it's a little simple series circuit. So I total is just going to be V total divided by R total. Ohm's law. I total equals 25 volts. That's our original given voltage over our R total just for this little simple circuit. Okay, that's that 5.7k ohms. So now our I total should equal, let's wake up the old calculator. Come on, calculator, it's time. Okay, so let's get rid of that old value. So 25 volts divided by 5.7k ohms is going to give me 4.386 milliamps. Now, the only voltage I really care about is the voltage of R2, the voltage between A and B. Can you see it? So I just need AB voltage. Okay, I'm looking for this voltage. Now, if I really want to be careful and double check, I can find both voltages and make sure that at least this circuit is all double checked and good, which is fine to do. Okay, so let's find VR2 first, because that's the one I really want. Okay, that's just going to be I total for this circuit times the value of R2. VR2 equals 4.386 milliamps times 4.7k ohms. Okay, VR2 equals, bring back the old calculator here, that current that we got before times 4.7 e to the third equals 20.61 volts. Alright, well, let's hang on to that number. So that should be our Thevenin, so let's hang on to it. I am going to double check my work just to show that happening. IT times R1, VR1 equals 4.386 milliamps times 1k ohms. Now I can almost do this in my head. That should come out to 4.386 volts. Let's see how my mental mathing was going. Never hurts to double check. Let's just see if the calculator agrees. Calculator's a bit more of a morning person than I am, although it is 5 a.m. and I'm the only one in the house awake. Alright, so let's look at that. So let's go back up and grab that current times 1 k ohms. Boom. So my mental math was working. Okay, now that's all good. So if it double checks, oh boy. Hello, come on. Alright, so if it double checks, Kirchhoff tells us that 0 volts equals minus 25 volts. Now I'm just going around my loop here. Okay, plus VR1 plus VR2. Alright, well, let's see what old Kirchhoff has to say about my math today. Okay, so minus 25 plus VR1 plus that, and sure enough I get 0. So good, good, and good. Alright, so VR2 as identified by where in the heck is A and B on this circuit, VR2 equals VAB, which is going to be my Thevenin value, and here it is. That is my Thevenin. Well, that's all great. Let's go back to our original and just look at what was the plan again. Well, we found R Thevenin, we found Thevenin.